Okay, so this is going to be a quick video overview of the Alkabot. This is a DIY open source alkalinity monitor intended for saltwater aquariums. The commands are sent over MQTT, which is commonly used for do-it-yourself home automation. So I'm just going to send a test command from my computer. As you can see, the middle pump here, which is the wastewater pump, has started running. So what that's doing is clearing out this reaction chamber, emptying it into this bucket down here. It's going to run long enough that it can be totally confident that that chamber is empty. It's going to run long enough to empty 50 milliliters out of there, which is the full volume of that chamber, although it's programmed to only ever load it up to 30 milliliters. Once that's finished, this pump here at the bottom, which is the tank water pump, is going to run 30 milliliters, fill that up. This stirrer motor here, magnetic stirrer motor and magnetic stirrer bar that sits inside the chamber there, will spin to rinse everything off, rinse off the inside of the chamber and the tip of this pH probe. And then the waste pump will run again to empty it, and then it will bring in a fresh load of tank water to run the test. So that whole process, that rinsing and reloading process, does take, I think, 3 or 4 minutes. I'm going to set my phone down and speed up the video while that happens, and then I'll pick this up again once it's doing something interesting. So the reaction chamber is now filled. It's woken up the pH sensor, which you can see here. The pH is reading 7.9. I can see it on my serial monitor on my computer, which is not quite accurate. The pH should be reading around 8.1, but I think that is probably because I ran a test on this just about 10 minutes before taking this video, so the probe did not have enough time sitting in clean water after the previous test to be completely clean now. But that shouldn't have too much of an impact. So it's just done a bit of a stir using those magnets. It'll be taking another couple of pH readings to begin, just to make sure that it has a reliable starting point. And then you'll see it start to dose. If you're wondering, by the way, what these randomly drilled holes in the front here are, the stepper motors that run these titration pumps are incredibly accurate. They're much more accurate than normal peristaltic pumps, which is why this does not need any sort of sensor counting the drops that go in there, because this pump can actually dose reagent at 0.1 milliliter accuracy. But the problem with the stepper motors is they create a horrendous amount of heat, and I hadn't taken account of that in my original design. So version 0.9.1 on GitHub is going to have a proper hole here for a 40 millimeter fan that will engage when the motors are on, and it's going to have some ventilation holes on the sides. What I've done on my prototype here is just used some spacers to make a sort of air gap in behind the front panel, and drilled a bunch of holes, and then realized I didn't actually have a 40 millimeter 12 volt fan, so I need to wait to put that on, but that's what that mess is for. It's just some ventilation, because I found it was getting so hot inside the casing before that it was throwing the pH values off, so that shouldn't be a problem anymore. What you're seeing it do here now is it's actually running the reagent backwards. So what happens is when it doses, if it leaves it with the fluid in the line, then because the storage chamber is above here, it's actually, once the USB cable's not hooked in, it'll just sort of sit in this top corner. Because it's above the reaction chamber, once that line is filled with water, it will continue to flow downwards because of gravity, even when the pump's not running. So after each dose, it runs backwards just enough to empty out that line, and then it runs it back forwards by that same amount before the next dose, before it starts counting how much it's putting through. And what it's doing right now, it's in the middle stage at the moment. It's got 3 stages of titration. It's got a fast, a medium, and a slow stage. So in the fast stage, it adds 0.3 milliliters at a time, and checks the pH. And if the pH is dropping very, very rapidly, then it skips a dose. If it's dropping by a more reasonable amount, then it will immediately do the next dose after it's had a few seconds to stir. Once the pH has dropped below 7.5, it moves into the medium speed titration, which does the same thing, but 0.2 milliliter doses. And then once it's dropped below 5.5, it goes into the slow, which is 0.1 milliliter doses. And what that does is keeps the sort of precipitous drop from happening and taking us way past the target 4.2 pH. Right now, according to my serial monitor over here, we have gotten down to 6.4. So it's continuing to add in that medium speed. Not sure what else to tell you, really. It is running on 12 volts. It's taking, while it's on, it takes about 18 watts to run the motors. When it's not running a test, just sitting there in standby, it's less than 1 watt. So it's quite power efficient. You can leave it on all the time and just send it a command when you want it to do a test. Oh, the reagent here. So I am using 0.02 m hydrochloric acid. I diluted it myself. I bought 1.0 m HCl, and that's diluted 1 part in 50. So that means that 17 pounds, I think, worth of acid that I bought is going to take months to use up. And the 0.2 is a nice compromise in terms of the amount that it uses in each test and the amount that it can hold there and the accuracy. So if you go higher concentrations, you'll use less per test, and you can leave it alone for longer without refilling it, but the accuracy will suffer. So at 0.2, this holds enough to run somewhere around 70 or 80 tests. So I'm going to have mine set up to test every 2 days, which means, I can leave it for 2 or 3 months without even checking the levels on the reagent. So we've reached a pH of 5.95 now after adding, looks like 2 milliliters of the reagent. So with any alkalinity test, what you're doing is measuring how much of a standard acid you have to add before it reaches a pH of 4.2. And what your handheld or done by hand test kits will do is you'll just add the acid manually and add a color change indicator. And so as soon as the color changes, that's your 4.2. any electronic system is going to use a pH probe like this. This, by the way, is an analog to digital converter one. Atlas Scientific are pretty widely available probe and board, and they're what I suggest. It is possible to take pH readings using an analog signal amplifier, and those kits tend to be a bit cheaper, like a lot cheaper, like £60 cheaper for the probe and the board together. But I really would not suggest that I couldn't get an accurate reading on an analog amplifier, given all the other electrical noise that's in here. The analog signal just doesn't cut it. You'll notice that that stirrer is running every time more of the reagent's titrated in, but then it stops for the pH measurement to be taken. And that's important too. The pH reading will be affected if the water is moving, especially since when I calibrated the pH probe using these standard solutions, I was not stirring them at the time, so that actually does impact your calibration. I'm going to put my phone down again, and I'll pick it back up when we've reached that 4.2. So it's finished the test. It's saying here, you can see in the monitor, it's saying alkalinity 7.65. That's actually a bit low. My true alkalinity, at least if the Salifert tests are to be believed, is about 8 to 8.3 right now. So I think that's just the result, as I said at the beginning of the video, of the fact that we started out with a pH reading that was a little bit lower than true, and that's probably just because there was still some acid hanging around the pH probe electrode, which should be dealt with by leaving it a bit longer between tests, because what it's going to do now at the end, it's going to empty out the reaction chamber there. It's going to fill it again from the tank water. It's going to run the stirrer a bit to just agitate everything, and it's going to leave that water there, so that you give it an hour, and any residue that's on that pH probe will theoretically just sort of disperse into that water, which will then be purged out, rinsed, and replaced with the next test. So all of this, telling you exactly what it's doing, that's just visible in the serial monitor when you've got it connected to a USB, but it will report that alkalinity number as a sensor over MQTT, and so you can do whatever you want with that on your home system. I have a Raspberry Pi that collects that data and puts it into Grafana, which gives me a graph that actually comes up here on my repurposed old Kindle that sits here under my tank. There's going to be an alkalinity monitor right there. So that's the system. As I say, version 0.9.1 with a few tweaks to the casing to allow for ventilation is going to be on GitHub very soon, next day or two. And the code will also be available in the next day or two. So you should be able to build one of these and get it running with your setup quite soon if you're interested. Quick update to all that. I've just waited about 2 hours and run the test again, and we've got our accurate alkalinity there of 8.2. So it really is just waiting for that probe to be properly cleaned. So This looks like it's ready for me to set it up here. I'm going to deploy it on my actual tank now, rather than having it running out of this measuring cup. And I'm looking forward to any of the upgrades that come from discussion with the community. There's a forum post for this on Ultimate Reef, if anyone wants to contribute ideas. And there's also obviously the GitHub issues and discussion features. But yeah, definitely looking for feedback and ideas. I'm interested in potentially implementing some kind of local control, maybe just a small OLED screen and a rotary encoder that you could use to run a test and view the result if you don't want to hook it up to a home automation system. But anyone who wants to jump in and fork some of the code for that or contribute to the project, definitely interested. Yeah, let me know how your builds go.